I've been thinking about how Garmin implement their their autopilots. If you have the same autopilot in a Cessna, is it 137 trainer and the, all sorts of other aircraft with different types of. Well, I don't know whether the AHRS is built into that autopilot interface, or maybe it's just a standard user interface, so that pilots only have to train to use the interface. And I was also thinking about how you build the software where you've got to handle all sorts of different configurations of accelerometers, magnetometers, differential GPS, pitot tubes, and then I guess there must be, you've got analogs of some of these things in underwater vehicles, and I don't know if there's any. Maybe now I should really look at Larry Paulson's software engineering notes. He did tell me that they were the most of all his stuff on his web page at the lab. They were the most referenced. They had the most hits. But I'm starting to see it. I'm starting to see everything as a control system now. I can't think about any calculation or anything outside of being part of some complex process of connections between cells in some abstract space. I'm wondering why the other day in my video I said it backwards. I'm talking about the bit of Gerald J. Sussman's Strange Loop 2011 talk, around 25 minutes 5 seconds it starts. He said stateful cells and stateless connections, and I turned it upside down. And I think it's partly because he kind of said it backwards himself, and it didn't. What he says doesn't match what's written on his slide. It doesn't quite. I mean, I think he corrected himself. You have to listen to it. But to me, it made sense the other way around. Stateless cells and stateful connections, because it seems to me like the only thing the system knows taking Putnam's externalism, the only thing you know about the semantics are the connections. You don't know anything about the actual, are they called the beables or the observables? Buen día.
Yeah.
Yeah, Putnam and externalism. So a physical quantity like the height of the tower, when you're trying to measure it using a ruler, a stopwatch, and what is it? An altimeter. You have different the units of measurement. You're always going to get a length, but the physical processes involved in determining that length you have a kind of network of interactions which is, in a way, which is your theory. These are all theory laden connections. And I suppose those aren't really what you think of as physical states. They're states of knowledge, or in a sense, as a whole, they're a state of knowledge. Maybe there's a kind of phase space of knowledge that's evolving. Maybe you can look at it like that, and then the different physical experiments take projections from that phase space of theory. So getting back to AHRSs, there's one paragraph in Peterson's master's thesis which kind of gives away a bit about how he's thinking about things. That he's talking about the say you have a 3-axis magnetometer, a 3-axis accelerometer, and an inertial gyroscopic thingy. He talks about when you're manufacturing the board, he mentions that you need to have these axes aligned properly in the manufacture, otherwise errors will feed. Otherwise they'll argue with each other, and they'll all exhibit biases in different directions, and that made me think, well, he's not thinking about it he's not thinking about the filter as a control system. He's thinking about it as having some concrete reality which is like his God's point of view coordinate system. Because it seems to me that those sorts of misalignments in manufacturing ought to be automatically compensated for by the filter convergence process. Somehow out of that process you ought to be abstracting more than maybe he is. Because if you look at Gerald J. Sussman's example of how you combine the calculations, the different perverse ways of calculating the height of a tower, there's a long list in that story, and there's the one where you drop the altimeter off the top of the tower and figure out and see how long it takes to hit the ground and things like this. And if you combine all of those different theories to produce this physical reality, what we have as a whole is human knowledge and human communication is a kind of abstraction process. The ontology arises out of is a kind of dynamic product of epistemology. But all we really have access to is the epistemology. So that's the sense in which I got it backwards. It's or maybe it's a duality thing. Maybe there are two. Maybe one of these is one half of the syntax semantics unity of opposites, and the other is the other way of looking at it. But back to software. You can. A little fun project would be to look at Bill Gosper's continued fraction operator arithmetic and write a scheme program or a Lisp or a standard ML program to model those computational streams, because that's really how Gosper models. Gosper's representation of continued fractions is as kind of data sources. So stateful data sources which you can keep calling to get the next level of the expansion. And you can build up expressions, and you can propagate the calculation back from the output to the input, or from the output down to the constants. But you can fit that into. Sussman gives an example of a Henon square root calculation process. Which can be modeled as these propagator constraint things. So what I'm thinking about is using that propagator constraint idea to actually compile assembly code which should be able to implement these calculations efficiently. And if it's the sources for these data things are literally hardware APIs, you ought to be able to do away with the need for the real-time operating system on a system like an autopilot, AHRS. You've just got this network of data flows and incremental computational processes all running. Ultimately, everything is running off the kind of interrupt handlers on the devices that are producing the data and consuming it. I don't expect anyone to what I'm just trying to get across is a very vague idea of a direction, I think, that seems to me that things should be going, so that we don't have huge clunky bits of software running on embedded computers, and we don't have firmware upgrades of tens or hundreds of megabytes of code, and horrendous possible security problems and things. When you think of the things you could do to crash planes of different sizes when they all run the same autopilot. And when it's full of libraries for doing all sorts of crazy shit. And I'm not even gonna think about how Tesla's cars, how the software in Tesla cars works. Let's leave that for another decade.